Hello and welcome back to Hydroponics Daily. Today we're talking about ultraviolet light and its effects on plants. Just like in humans, it can have some positive effects and it can have some deleterious effects. So in humans, it's normally negative. It mutates DNA, damages your skin, but it can have positive effects where it's in low levels. It's important for the generation of vitamin D. Maybe there's some other positive effects. I don't know. I'm not an expert when it comes to human animal biology. I think it can also cause cataracts as well. But don't quote me on that. In plants, again, it can damage DNA and photooxidative damage to the other cellular apparatus, like the chloroplasts and things like this. Most plants growing outdoors don't suffer from a major impact of ultraviolet light, certainly not damage, because they become acclimatized to it, acclimatized. They develop systems in their cells that mean they're able to cope with UV, sort of natural sunscreens, things like this. You do have to be careful when you're transitioning plants from a grow room or a greenhouse out into the outdoors, especially in the summer when there's high light levels. I once took azalea plants outdoors, out of a grow room, and put them outdoors in the summer, and they all went red within an hour. All the leaves went red because they've suddenly been exposed to ultraviolet light, which they'd never had for their entire life period. So azaleas, they can grow up in the subalpine areas of the mountainous regions, and so would be exposed to very high levels of UV light up there normally, but the defense mechanisms are turned on. They're not always on. They're not constituent. They have to be activated. So that's something to consider. And one of the most sensitive parts of the plant to ultraviolet light is actually the pollen. Pollen can be extremely sensitive to ultraviolet light. Plants exposed to very high levels of UV light produce far fewer pollen grains. They're not as healthy. That could be a way of actually controlling pollen in dioecious crops where you don't want pollination. You could actually just have high levels of UV light in your grow room as well. That might be one of the advantages of UV light. As we say, it can also affect the photosynthetic mechanisms in the plant. And there's two key adaptations to high light levels and UV exposure, and they are trichomes. So they can help with protection against UV light as well as pests and diseases. And there's also the presence of those protective pigments as well. Anthocyanins being the key one, anthocyanins. So as I said, many of these pigments are induced, and a great example of that is the lettuce variety Lola rosa. Without any UV light, it will tend to be a green colour. But in the presence of UV light or blue light in a greenhouse or a grow room, it will turn red, or certainly become more red. And that's because of the anthocyanins being built up and in those lettuce leaves. So people have started to look at including UV lights with grow lights to improve the growth and the production of pigments and secondary metabolites. So a plant that's been exposed to ultraviolet light can be extremely high in antioxidants to mop up any of the reactive oxygen species that have been created when UV light hits a cell and would otherwise cause a lot of damage to the structure and the DNA. So a number of plants like coleus, kalanchoe, the succulent, chrysanthemums, they've all been found to produce more intense colouring when exposed to UV light. And so that those pigments are in the flowers, again, protecting the cells. And then in plants where you want pollination, the UV, is important for the nectar guides, these specialists almost like runway lights on the petals that show bees where to go to get the nectar, and they aren't visible in the visible spectrum. They're only visible when the plants are exposed to UV light. So in a UV-less environment, they won't be visible to the bees because there'll be no UV light around. In some Californian orchards and Japanese orchards, they have a practice of placing bags over the fruit just after pollination and then right up until shortly before harvest. A bit like the forced vegetables we talked about in a previous episode. And the practice does not affect fruit shape, but removes most of the chlorophyll. And when the bags are removed just before harvest, the anthocyanin pigments produced due to the UV light they suddenly get restarts in the skin, and as a result the apple produces a very distinct pink hue which can sell for a lot more money than a standard apple. Some apple growers have even experimented with painting sunblock on the skins of ripening fruit, and the sunblock intercepts the UV radiation, and when it's washed off the leaves, the fruit can have this picture of a supermarket logo on due to the cells underneath having different pigment. Might try that with the Utrema or the Gold Leaf Liquid Gold logo. That'd be interesting. And the variety chosen is often the Fuji apple. So if you're looking to experiment with that, paint it on some sunblock, try it on some Fuji apples. UV can also be important for hardening the plants up, ready for winter or for other environmental stresses. So it hardens up the tissue, makes it more resilient. The leaves will be thicker and tougher. So I talked about in a previous episode, if you put buddleia in a UV-less environment, the leaves become massive, whereas outdoors, they are smaller and thicker because they are exposed to UV light. We talked about antioxidants, and obviously there's going to be loads of antioxidants in plants exposed to UV light and fruit. So things like ascorbic acid, which is vitamin C, beta-carotene, which is vitamin A, vitamin E. These are all much higher in plants that have been exposed to UV light, and studies have shown that. Unfortunately, no supermarket's prepared to, market fruit and vegetables on their antioxidant content, so there's not necessarily a market for that. Whereas in other crops, having a increased taste and odor and bioactive ingredient levels could potentially be important, especially medicinal plants. So there was a lot of research on compact fluorescent UV lights in different grow environments. And now there's a lot of research into LED UV lights. They've been trialed for killing off storage molds and also improving antioxidant levels. UV LEDs used to be very expensive. Anything in the blue range tended to be more expensive. However, they're becoming more commercially available now. You're seeing a lot of products that contain UVA bands of the spectrum. There's UVA, UVB, which are the natural wavelengths found down here on Earth, and UVC you wouldn't find naturally. The atmosphere absorbs all of the UVC normally, but you can get UVC bulbs. However, they're particularly high energy and you need to be careful with your eyes. Any UV, always wear eye protection and don't be in the grow room when the UV is on. However, with UVC and UVB, that's very important because you could get serious eye damage and skin damage. So UVA can be with plants, it's thought that UVA lights, when they're incorporated into a grow light, can be used continually, whereas UVB, you would want to only put that on for a few minutes every day, and certainly UVC. There's a number of big UVC growers manufacturers of equipment with UVC, and they go down strawberry farms now and go down the aisles of the orchards and the farms and treat them for molds, things like grey molds with UVC. However, you need to be careful because if your workers were exposed to UVC light, there is a liability there as well. So you need to make sure all the safety considerations were taken care of. So you can buy specialist UV lights for hydroponics. However, I tend to use just the UVB light that you can get for reptiles, and you go to a pet shop and you can buy a UV light for them. And I just tend to put that on a timer for 15 minutes a day in my grow room if I wanted to have UV effects. You certainly play around with it. I think compact fluorescent is probably, you don't need to have it incorporated into the grow light. It doesn't need to be evenly distributed. I don't think, as I say, the light for photosynthesis does to produce a uniform crop. However, if you've tried compact fluorescence and you think that LED lights are better when they're incorporated into the grow light, let me know, and I'm happy to be proved wrong. Certainly, as an entry point, a compact fluorescent compact fluorescent UV light is the best entry point. It's going to cost you maybe £30, $40, something around that road. Whereas a UV incorporated grow light might be a lot more. There's also grow lights with far red lights. I'll talk about that, what crops that benefits and what crops that probably is not good for in a later episode. So that's been Hydroponics Daily for today, UV light and its effects on plants in hydroponics. If you'd like to know more, please get in contact with me, and if you make sure you don't miss an episode by clicking follow on your podcast provider of choice. Until tomorrow, thank you very much.